What does karaoke have to do with mathematics? I'm doing a series where I try to connect topics that people don't usually associate with mathematics to mathematics, and this is episode number 1. Welcome to The Maths Behind Karaoke. One of the main challenges of singing karaoke is finding songs that don't already contain the voice part. During research, I found out that actually many old karaoke machines had a mode specifically for disabling the voice of songs automatically, and they did that by exploiting the fact that on stereo recordings, the voice is usually placed in the center, meaning that it gets shared between the left and right channel of the stereo recording equally. So if you just subtract the left from the right channel, usually only the instruments are left. Of course, as you can imagine, that actually doesn't work too well because songs just don't always do that. So people came up with a new way instead, and to understand that new way, we first need to learn a thing or two about signal theory. A song, or in general a sound, is just a series of air pressure changes, and we can represent these as a signal, just like this one, which is basically just the plot of the air pressure over time. We can also generate sounds by making speakers create these air pressure changes. If we create a wavy pattern like this one, a sine wave, and play in 440 times a second, it sounds like this, which kind of sounds nice. And it turns out if we add many different sine waves on top of each other, we can actually create all possible signals. Kind of. For example, to recreate a square wave just like this one, we need an infinite number of sine waves like this. And if I draw some random signal here, you can see that it too can be made up by sine waves. This was theorized by French mathematician Joseph Fourier in the 19th century. Calculating which sine waves exactly make up a given signal is really hard. There are some clever ways to do it, like the fast Fourier transform, which some people claim is the most important algorithm ever created, but for now just accept that there is a way to figure out which frequencies lie in specific signals. And that's exactly what modern karaoke machines, at least some, use to remove the voice from songs. They look up the frequencies from the song at any given point, look at what frequencies normally correspond to human voice, remove them, add up all the sine waves again, and play the song without those frequencies, thus producing a song without the voice. Or, and this is a big or, you just sing along to the instrumental version or the karaoke version you find on YouTube. I've been told that in Japan, some artists even release official karaoke versions, which makes things easier, I guess. However, this technique of extracting the base frequencies is actually really important and really fundamental, not only in maths, but also areas like electrical engineering. In fact, I think your phone is probably doing hundreds of fast Fourier transforms right now just for you to be able to watch this video, which I think is pretty awesome. Thanks, and thanks for watching, and see you next time. Bye!